Hello, friends. This is our practice quiz, and you are going to be given the choice to use either this practice quiz or your notes on the actual quiz. So I'm just going to go through this and explain it and hopefully help you in case you have any questions. So determining yes or no on on function is going to be the vertical line test. And since any vertical line I draw here only crosses the graph one time, meaning it crosses here, 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 and so on, one place at a time, then that's passing the vertical line test. And so then that means that this is a function. Domain goes from left to right, range goes from bottom to top. Domain uses x's and range uses y's. Keep in mind that the y's go up and down. Positive infinity is up, negative infinity is down. X's go left to right, positive infinity is right, negative infinity is left. So here when I'm going to the left, you can see there's an arrow, so that means it's going forever to the left, which you can never get to, so you don't use or equal to. The alligator mouth's always open to the right for this. I put an X in the middle because it's domain, and then it actually does stop right here at 2, but the catch is it's an open circle, so I don't use or equals to. Range is going to go from the bottom to the top. The lowest it ever goes is right here also, and that's at -2 on the y, but again, it's an open circle, so it still doesn't touch. I'm doing range, so I use y, and then even though this looks like it's going out, it's also going up slowly but surely, so that's going to go up forever towards infinity. This part's really confusing, people, and it's not actually that confusing. Whatever's in here is an x value. So it's like saying if you go to 2 on the x, what's the y value? What's the point? Well, that one actually is open, so this one's kind of unique because it doesn't have a solution. But here, when x is -2, you can see that the graph appears to be crossing the x-axis. It's sort of imperfect. It's hard to see, but I would give that a 0. Here you can see that this also passes the vertical line test. This part looks dicey, but this is not really vertical. It's just curved. And so since it passes the vertical line test, I'd go with yes. It does not go forever. It starts here on the left end at -1, 2, 3, 4, 5. And it actually hits that value because it's colored in. So I give it or equal to. On the right end, that happens at 1, 2, 3, 4, +5. But that one's open, so I leave the or equals to off of there. So these indicate whether the dot was open or closed, meaning included or not. The lowest it ever goes is right here, and that hits the y-axis, so that's 0. And it actually hits it, so that's or equals. I'm doing range, so that's y. And this is the highest spot, which is at 1, 2, 3, 4, 5, 6 on the y. But because it's open and never touches it, I leave it without the or equals to. F of 2 has a dot right here. Here's the 2 for x, and then it's got the dot. I know it looks like it hits here, but it's not supposed to. It's supposed to be like a little curve that goes close to it. But they got the big old dot there at +3, sorry. So this is a 3 because I made it so blobby, but you can see from the original graph that over 2 up 3 is a point. And then at -2, which is right here, it's up 3 as well, because they're both on a horizontal line. So every point on this horizontal line actually has a y value of 3. This one fails the vertical line test because it crosses here and here. So that's going to be a no. And then the domain goes forever to the left. You can see that. And then it stops right here. This graph is counting by 5s, which is kind of hard to see. So this point right here is over 5, 10, 15, and then up 5. And so the domain value for that one is a 15, and it actually touches that value of 15 on the x. The lowest, this goes out forever, but it also is going down, and this one's going up. So this one's actually all reals, meaning it goes up and down forever. So that's going to be like that. F of 2 is really hard to see because it's counting by 5. So you just have to do a good estimate on this one. Because at 2, you'd be like here, and it's up 5, 10, 15, and a little smidge, so maybe 16-ish. I would never do that too on a quiz where it was that hard to read. And then here at -2, you're up about I don't know, 5, 10, 15, a little bit more, so maybe 18-ish. So those don't have to be exact. It's just the concept of being able to find that. Okay, so then let's take a look at linear. Linear simply means that it's going to create a line when you graph it, and that means that it has to have just a plain old x. It's not going to have like x squared or absolute value. It's just going to have a plain x. So this one is actually, it's written with this notation, but this is just y equals negative 3x plus 2. So that is plain x, linear, yes. This one has an x squared, you can see right here. So that's going to be a no. And this one has these weird absolute value bars in it. So that's not going to generate a line. And so therefore that is not going to be a linear graph. Whether it's linear or not, you can find these function values. You simply are plugging in the number. So I'm copying the original problem, but where there was an x, I'm putting in a negative 7. And then if you put it in parentheses, your calculator will always do the PEMDAS process correctly. And I get a 23 on that one. Here I'm plugging in a negative 1. So again, it's negative. It's always confusing when it's negative, because the negatives and positive can get messed up really easily. So I went ahead and put in that negative 1, use my calculator, and I get out an 11. On the last one, this is, if you don't know how to put this on your calculators and think it through, negative 3 times the absolute value of 1. The absolute value of 1 we learned in chapter 1 is just how far is that from 0. So it just turns into negative 3 times regular 1. So the answer is negative 3. And you can have an absolute value problem that turns out negative when that negative is on the outside of the bars. Okay, find the slope through the points. Keep in mind that to find the slope through the points, we need to use the slope formula. So we would be taking our y2 minus y1 over x2 minus x1 over and over and over again. You're going to do that so many times. Okay, so here I'd have 8 minus 4 because I start, here's x1, y1, x2, y2. So 8 minus 4 over negative 1 minus negative 3. So that definitely gets confusing. This is a regular 4, but this turns into negative 1, which I somehow made look like a 7. Negative 1 plus 3, which is a 2, so I get a 2. And then rises, falls, vertical or horizontal. This basically means is your slope positive, negative, undefined, or 0. And this one's positive, so it rises. Okay, I'm probably going to run out of space here to show my work, so I'm going to do them in different colors so that maybe you can keep it straight. So in the second one, I take my second y minus the first, my second x minus the first, so x2 minus x1. But when I do that, you can see what's going to happen on the bottom. I get on the top negative 6, but on the bottom I get 0. If you can't remember whether that's 0 or undefined, try it on your calculator and you're going to get an error. You can't divide by 0. So you're going to get undefined slope, which means it is vertical. In the next one, I am going to feel red here. Negative 3 minus 4 over 2 minus negative 7. So I get negative 7 on the top. And again, if you're really struggling with the negatives, use a calculator. And on the bottom, these will add together to give me 9. The value of it doesn't matter. I mean, I'm not graphing. So I'm just determining what it does. And this falls because it is negative. Last one, I feel like that should be green. Now this one I'm going to get 9 minus 9 on the top. So you can kind of see where that's going. 8 minus negative 5 on the bottom. So on the top, I get 0 over 13. If you go to your calculator and you do 0 divided by 13, it's going to give you 0 because that's okay. And that means you would have a horizontal line, which you guys, it makes sense because if you look at these points, if you went to negative 1, 2, 3, 4, 5 up 9, and then you went to positive 8 up 9, they're going to both be up 9 and create a horizontal line. And remember, the equation would be y equals 9 because it's telling you what the y value has to be. and it's crossing only the y-axis. So for parallel, I need the slopes to be the same. Perpendicular, I need them to be opposite in sign, and then reciprocals. So I need them to be positive, negative, and flipped over, both things. Neither means that it doesn't meet any of the criteria for parallel or for perpendicular. When it says show your work or show your calculations on a quiz, you got to do that because that means it's tied to some points. So let's go ahead and find the slope for line 1. 1 minus 3 over 7 minus 1 is going to give me negative 2 over 6, which reduces to negative 1/3. And you should always reduce it so that you can compare them easier. In the second one, I'm going to have y2 minus y1 over x2 minus x1. I end up with 6 over 2, which reduces to 3. So I'm comparing. They're obviously not the same, but they are opposite reciprocals because one's positive, one's negative, and 3 is the same as 3 over 1, which means it's the flipped version of 1 over 3. So they're opposite reciprocals, and therefore those two lines are perpendicular. Doing the same kind of math over here, I'm doing y2 minus y1 over x2 minus x1. This becomes a 9. This becomes negative 6. That reduces to negative 3/2. And I always just put the negative on top because it's kind of weird to have it on the bottom. And the second slope, y2 minus y1 over x2 minus x1, these become adding over negative 1. I get negative 3 or 3 over 1. So these two are not the same. So it's not parallel. And they're not opposite reciprocals. They're both negative and they're not flipped over. So this one has to be neither. The lines wouldn't be parallel or perpendicular. So the concepts so far are kind of understanding domain, range, finding these values, vertical line test, when is something linear and how do I plug numbers in, finding the slope to decide if it rises, falls, vertical or horizontal, and then deciding if things are parallel or perpendicular. The rest is graphing and kind of applying word problems. So let's take a little peek at that. The slope of the line parallel to means same. So if you're looking at this equation, you got to figure out the slope. Well, this equation is in slope-intercept form, and this is the slope. So the slope of this line is 4/5, and if you want to be parallel to that, you have to use the same slope. If it had said perpendicular, if it doesn't, but if it had, then I would have had to say negative 5 over 4 because I would have had to change it to the opposite sign and flip it over, but it doesn't. It says parallel, so I use 4/5. I keep the same slope. Fill in the missing value to make this vertical. Okay, vertical, you guys, means that this other point, negative 1, 2, 3, down 2, if you want to have a vertical line, the other point has to be on that same x value. So vertical lines, remember, have x in them only because they only cross the x-axis and they tell you where. So this has to have an x value of negative 3, just like the other one. So if I went negative 3 up 1, 2, 3, 4, 5, and negative 3, negative 2, I end up on that same vertical line. Because vertical lines have x equals a number, and horizontal lines are y equals a number. Okay, so this is slope-intercept form, and it gives you a hint. It says use the intercept as a start point, and that's going to be on the y-axis because it's the y-intercept, and then the slope to move. So in this particular problem, this one's ready to rock and roll. I'm going to go ahead and start at negative 3 on the y-axis. So down 1, 2, 3. It's super popular thing to do wrong to start on the x-axis, but you don't. You got to start up or down. And then this slope is telling me, since it's positive, to go up 2 over 1 to the right from that negative 3 point. So up 2 over 1, up 2 over 1, up 2 over 1. And then I'm just connecting those dots, and then I'm going to be super grateful for Notability straightening that out for me. Okay, don't overthink this one. This is only going to cross the y because that's all that I see in my equation. And if it's only crossing the y at -2 and it can never cross the x, then it has to be horizontal going through -2. Okay, this is like having plus 0. So I'm starting at 0, and then my slope is telling me, and slope is always attached to x, so it's telling me to go down 2 over 3, down 2 over 3. And so then that is going to be the line I'm looking for. Now, your lines don't have to be perfect, but I do want to be able to see that you crossed the right spot and then you counted the right amount. So I'd kind of be looking for those points that show that you know what you're doing. Okay, these are standard form, and it says make the table with the zeros to find the intercepts to connect. So that's the easiest way to do this, is to make that XY table where you put a 0 in for each thing. If I put a 0 in for x, then the x part goes away, and I'll be solving -6y equals 24, which will solve to be -4. In the second step, when I'm going to go ahead and put a 0 in for y, that crosses off this part, and I'm left with 3x equals 24, so 8. So that's telling me that 0, -4, down 1, 2, 3, 4 is my y-intercept, and positive 1, 2, 3, 4, 5, 6, 7, 8, 0 is my x-intercept. And so then I just connect those two lines, connect those 2 points to get the line. So I want to see those 2 points and then do the best you can to connect them straight. Don't be freaked out by this thing. This is x equals 1. So it doesn't have both an x and a y. It's not going to be slanted. It's only going to cross the x at 1. And if it's never, ever, ever going to cross the y, then it has to go straight up and down right alongside the y and be parallel to it. So that's going to be a vertical line. And you want to get those 2 exceptions, that y only crosses y and is horizontal, and x equals equation is going to be vertical and only cross the x. Okay. And then here in this one, I get, again, I'm going to put the zeros in. If I put a 0 in here, that'll go away. What's yucky about that is -28 divided by 6 is not like a nice pretty number, but I'm still just going to show it in my table. So -28 divided by 6 turns out to be -4.6 repeating. And so, excuse me, I'm going to go ahead and plot that on the y because it's under the y. So down 1, 2, 3, 4.6-ish. And then for the second one, it's saying to put the 0 in for y, so that part will be gone. And in that case, when you divide by -14, that actually comes out to have an x value of +2. So graphing 2 on the x is going to be right here, and then I can connect them. So if you have that standard form, I think it's easier to just make that little table and figure out where they cross the axes than to change it into the other form. Okay, so this is a K problem. You want to know how to do these. Show all your work to find the value of K needed for the slope of the line through the point to be -2. Okay, so you know the formula. You know that slope equals y2 minus y1 over x2 minus x1. So they just told you over here at the end of the problem that the slope is -2. I'm going to put it as -2 over 1 because every whole number is over 1 and it'll make it easier for me. Now I'm going to do y2, which is k plus 1, and I'm going to subtract y1. Then I'm going to do x2, which is -3, and subtract x1. So I end up with -2 over 1 equals, can you see here that these two combine and become a k minus 1, because positive 1 minus 2 goes together. And then on the bottom, -3 minus 1 more is -4. So I'm going to go ahead and cross multiply because I need to solve for k. So these two get multiplied together. And then these two get multiplied together, but 1 times k minus 1 doesn't change anything because when you distribute a 1, nothing changes. So this is where I'm at. So by adding 1, I find out that the k value that will make that true is 9. So that's something worth practicing or writing some notes to yourself about or having available during the test so that you feel confident about that, because that can be tricky, but that's going to be one to kind of take a look at. Okay, Patrick's Plumbing. It costs $100 to show up and $75 per hour. Write an equation, oopsie, I spelled that wrong, in slope-intercept form, showing the cost as a function of hours. Okay, so it's $100 to start with, and then anytime you see per, that's going to be your slope because slope is a rate. So the cost equals $100 plus $75 per hour. Or I'd probably, because I'm a math teacher, write it like this, just so it seemed more familiar to me as kind of slope-intercept form, because it's kind of y equals mx plus b. Not important. You could write it either way. Now you're going to use that equation to answer these other two questions. If your plumbing job takes 4 hours, so they're giving you h, you're going to go ahead and plug that in for h. It says show your steps to find the cost. The cost is going to equal 75 times 4 hours plus the $100 that it takes just to show up. And so then when you plug that into your calculator, you're going to find out that that's going to be a $400 plumbing fix. If your, apparently I can't type it all because that should say your, bill is $625, how many hours did they work? Okay, so here I have the cost. I'm still using this formula from up above, but I know that the end result is $625. And so I'm going to go ahead and put that in, but leave h as a mystery because that I don't actually know. And so I'm going to leave that as a mystery and solve for it. Okay, so we're just solving like regular. Take away $100 from both sides. So now 525 equals 75 times h. So I'm going to divide the 525 by the 75. And it's telling me that that is going to be 7 hours of work. That is one clogged toilet for 7 hours. Okay, so hopefully that helps. If you do a better job like looking at practice problems, the only thing I'm concerned about is that up at the beginning, this didn't have like deciding if something's a function based on mapping diagrams or tables. So keep in mind, like if I had a mapping diagram where these are my x's and these are my y's, it's okay if a bunch of them go to the same thing. So that would be a yes. But if I had a 2, a 3, and a 1 going to 4, 5, 6, and it was like this, then that's a no. And the reason it's a no is right here. This x split into 2 y's. Everybody can go to the same y, or you can go straight across, but this is the thing that makes that not a function. And if I had a table of values, the thing that would make that second one not be a function would be the same kind of issue in that when you see the table, when you see the table written, it's going to have a 2 going to 4, and then later a 2 going to 5, and then 3 goes to 6, and 1 goes to 6. So this is the part right here, that repeat x, that's problematic. Versus here in the first example, 2 goes to 4, 3 goes to 4, negative 1 goes to 5. I don't care if the y's repeat, but these are all individual. And since the x's don't repeat, this is still a yes, and this would be a no. So that's the only thing that's not on here that I would worry about. So choose the thing that will help you the most on your quiz, whether it's this review sheet or your whole notes packet. Have a great day, guys. Bye.